Hello everyone, I am Sri Prakash, Research Scholar, Department of Electrical Engineering, IIT Varanasi. Okay everyone, let's start the session today. This some transient questions. As the switch is moved from A to B at t is equal to 4 seconds for the given network as shown in figure, find the voltage across the capacitor at t is equal to 10 seconds. Here the switch is closed at t is equal to 4 seconds, not a 0 second. If the switch is closed at 0 second, then the circuit is different. But here the circuit is closed at t is equal to 4 second. Then you have to try solve this question according to the given question statement. and the voltage is asking across the capacitor at 10 second. Okay, same thing, if there is given a 4 second, then 4 second is your initial point. Like if it is given as t is equal to 0 second, and 0 is the initial point of that circuit. But here is a 4 second, then you have to take the 4 second as a initial point. Then you have to make a circuit at t is equal to 4 second, 4 minus, like a 0 minus in previous. Okay, what is the circuit before the 4 second? T 4 minus, it means just before the 4 second. Then that time circuit is closed to A, 36 volt, a resistor of 80 ohm, and the capacitor looks like that in open circuit because of the steady state previous to that, and remaining circuit looks like that. You have to find this voltage. VC this is the 80 ohm, this is a 20 ohm resistor. In this case, the switch is circuit is open circuit, then total voltage is appears on the capacitor. It means the initial voltage of the capacitor at 4 minus is the same as 4 plus, which one is equal to 36 volt. The total voltage appears on the circuit capacitor. Okay, next one, same t is equal to at infinity, final value. What is this that time? This time is this circuit again, capacitor behaving like open circuit, and switch is closed because 20 ohm resistor. In this condition, what is the VC at infinity equal to 0 because of the total voltage is discharged of the capacitor till the uh, infinity time. Then what is the tau? Tau is RC resistance. You have to find the resistance after the 4 second. Then this is 20 ohm, and capacitor is given as 0.1 farad, 0.1 farad. Tau is equal to 2 second. Okay, what is the voltage? You know the formula of the capacitor voltage, V infinity plus VC initial. Here the initial is 4 second, not 0 second, minus VC at infinity into t e to power minus t by tau. Final value is 0 at infinity. Initial value is 36. Yes, 36. This will be 0 because of the all the energy of the capacitor is discharged till the infinity time, minus t by tau is 2. Okay, here this, if switch is closed at t is equal to 0, then this will be e to power minus of t by tau. But here switch is closed at t is equal to 4 second, then this will be e to power of minus t minus 4 by tau. This is 4 second delay. It means after 4 second. After 4 second, it means there is some delay. The delay signal is denoted as negative. Advance signal is denoted as positive. This is a delay of 4 second, then this will be a t minus 4. Here e to power of t minus 4 d by tau. This will be 2. Then what is the final value of the capacitor? So it's on 36 into e to power of minus t minus 4 by 2. But in the question asking the capacitor value at 10 second. We see at 10 second. T is equal to 10 second. Then 36 e to power of minus t is equal to 10 minus 4 divided by 2. This will be 36 e to power of minus 6 by 2. This will be 36 e to power of minus 3. We have to compute this one. E to power of minus 3 is equal to 0.0497 into 36. This will be 1.792 volt. 1.792 volt. It means within 6 seconds. It start from 4 and is asking at a time of 10 second. Within the 6 second, the 36 voltage dropped to 1.792 volt. Okay, simply you have to take the initial point here is 4 second. If the same circuit is closed at 0 second, then we have to equation is t e to power of minus t by tau. But here the switch is closed at is equal to 4 second. Then we have to take the time according to the given questions. E to power of minus t minus 4. It means because of the after 4 second. Okay. This is the next question. In the circuit shown in the figure, the switch is closed for a long time and it is open at t equal to 0. Before t is equal to 0, the circuit is closed to this like that. After 0, this will be open. The value of current of IL at initial point and capacitor current at initial point. This is the IL, this is the IC. IL may be same at t is equal to minus 0 minus and t is equal to 0 plus. Because of the inductor current is not allowed to change sudden change. But in the capacitor capacitor does not allow to change the voltage variation. But here in the question asking about the current, it means the current will change. Voltage will not change, but current will change from 0 minus to 0 plus. Then we have to make a circuit according to this. Circuit at t is equal to 0 minus s. Someone have doubts? First of all, we have to make a circuit at t is equal to 0 minus. In this case, this circuit, this is a voltage source. This is a resistance of 10 ohm. This is a 20 ohm. And switch is closed. This is 10 ohm resistor. Inductor will be short circuited and capacitor will open circuit. 30 volt. This is a 10 ohm. This is a 20 ohm of resistor. This is a 10 ohm resistor, 5 microfarad, and this is a 2 millihenry. Okay. This current is IC and this current is IL, inductor current, given in the question. Okay. In this case, you have to calculate the initial voltage of capacitor and initial current of the inductor. This is a short circuited. This whole part is short circuit. It means this is also short circuit. There is no meaning of this resistor. Circuit will close like that. Okay. There is no meaning of this resistor because of the this is the short circuited. All the current is flowing through the short circuited, not the resistor. Then what is the current? In this loop, this is the IL, whole current is flowing IL. You can apply the KVL. This will be minus of 30 volt plus 20 IL plus this is a 10 IL is equal to 0. What is the IL? At initial point you can say 0 minus, it will be same as 0 plus because of the inductor does not allow to sudden change. This will be 30 divided by 30, 1 ampere. It means initial current of the inductor is 1 ampere. Then what is the initial voltage of the capacitor? This is initial voltage VC 0 minus. This is, you can see, this is a connection of this one is across 20 ohm resistor. It means the voltage drop across 20 ohm resistor is same as the initial voltage of the capacitor. Then you can say VC 0 minus VC 0 plus. Initial voltage 0 minus and 0 plus is the same because the voltage will not change in capacitor, sudden change in capacitor. This will be a voltage drop across the 20 ohm resistor. It means 20 ohm resistor into IL. IL is 1 ampere. This means this will be 20 volt. Okay. IL, we have find the IL. Who found the IL? It will be 1 ampere initial because of this will be same. But here is the capacitor current. Asking the capacitor current. Capacitor current will change. Here the capacitor current is 0. Here capacitor current is 0. Why? Because of this is the open circuit of the capacitor. But you can't say that this is the same current after the t is equal to 0 because of the capacitor current will change. Voltage will not change. You can say this is a 0 minus is equal to 0 ampere. But you have to find IC at 0 plus. Then you have to make a circuit at t is equal to 0 plus. What is the circuit? This will be a open circuit in this condition. Sorry. This is the open circuit. It means circuit is closed like from this one. And you know at starting at initial point capacitor will short circuited and the inductor will be open circuit. then you have to make the circuit accordingly. Inductor will open circuit with initial current, which one will be 1 ampere, which one is 1 ampere. In capacitor have some initial voltage of 20 volt. Okay, and at initial point capacitor will short circuited, then a resistor is connected, which one is a 10 ohm, this resistor, and this is the IC at 0 plus, voltage is same 30 volt. This resistor is 10 ohm and this resistor will be 20 ohm. Okay, now you have to find the capacitor current. This current is 1 ampere. You can say this current is 1 ampere. Okay, this current is IC. This current is IC 0 plus, this current is 1 ampere. Then what is this current? This current will be IC 0 plus 1 ampere. Okay, then simply you can apply the KVL. Actually you can't apply the KVL here because of you don't know about the voltage across this one. If you don't know about the voltage across this one, then you can't apply the KVL here. Then you have to apply the KVL in this loop 1. Okay, I start from this one, minus of 30 plus this will be 20 plus this current is IC 10 into IC 0 plus, then after this resistor plus 10, and this current is IC 0 plus 1, it will be 0 current to the KVL. This will be minus of 10 plus this will be 10 IC 0 plus this will be also 10 IC 0 plus 10 is equal to 0. 10 will be cancel out, 10 IC will be 20 IC 0 plus, this will be 0, then IC 0 plus is equal to 0 ampere. There is no current through the capacitor after t is equal to 0. Okay, then in the question there is a option D is correct, 1 ampere of the IL and 0 ampere of the IC. Okay, let's go for the next question. Calculate I2 in circuit shown below at t is equal to 0.3 second. In this condition, the switch is closed at t is equal to 0. You know, the arrow is there. This arrow is shows that t is equal to 0, circuit is closed. Before t is equal to 0, this will be open circuit. In open circuit condition, the initial current of the inductor will be 0 at t is equal to 0 minus the circuit will be open circuit. In this current condition, I2 is the same as IL. I2 0 minus is equal to I2 0 plus, it will be 0. Initial current will be 0. Then what is the final current at t is equal to infinity? Circuit is closed. Then again short circuit at t is equal to infinity. This is 24 volt. This is I 12 ohm. This is I2 4 ohm and 8 Henry. In this condition, both in the resistor are connected in parallel. Then what is the I2 at infinity? Only this resistor is connected across this source for I2. That means the I2 is voltage divided by a resistor is 4 ohm. This will be a 6 ampere. Next one, we have to calculate the tau, because of you know the I2 equation, current equation. This is the I infinity plus initial plus I infinity, sorry, minus e to power of minus t by tau. In this condition, infinity is 6 ampere, 6 plus initial is 0 minus 6 e to power of minus t by tau, then final is 6, 1 minus e to power of minus t by tau. Okay, we have to calculate the tau. Tau mainly L by R. Here is R is more than 1, it means we have to calculate the R equivalent. How can you calculate the R equivalent of this circuit? For the R equivalent, we have to calculate the RTH, Thevenin equivalent. R equivalent is same as the Thevenin equivalent R. Then this circuit have a short circuit of voltage source and open circuit of current source. There is a voltage source, this will be short circuit. You have to open that point, which one you want to find the RTH. You have to open that circuit. This resistor is 4 ohm, this is resistor is 12 ohm. Then what is the RTH in this case? Anyone can guess what is the RTH in this case? Someone says 16 ohm. Okay, okay. 4 ohm. Okay. Here This is the short circuit. It means the whole current is passing through this, not this resistor. It means there is no meaning of this resistor. If there is no meaning, that means the current is passing through like that. Only 4 ohm resistor is there in this path. That's why the RTH is 4 ohm. Then R equivalent is also 4 ohm. Then what is your circuit? I2 current I2t is equal to 6 into 1 minus e to power of minus t by tau. Tau is L by R. L is equal to, given in the question is 8 Henry and R equivalent is 4. This will be a 2 T by 2. Okay. But in the question is asking the value of the current at t is equal to 0.3 second. Then I2 at 0.3 second. This will be 6 1 minus e to power of minus 0.3 divided by up 2. This is 6 1 minus e to power of minus 0.15. You have to calculate this one by your calculator. This will be 0.835 ampere at t is equal to 0.3 second. Okay, you have to take care about that this type of circuit where the resistor is more than 1 or the inductor is more than 1. In that case you have to find the equivalent resistor or equivalent capacitor or equivalent inductor. In that case you simply you have to apply the RTH method to find the equivalent capacitor, inductor and resistor. Okay, but remaining and all the remaining circuit is same. We have to find the initial point and after final point, and we can use the formula of final plus initial minus final into e to power of minus t by tau. Then after you have to calculate the tau and we will get the final answer. Okay, next, in the circuit switch is moved from 1 to 2 at is equal to 0. Then determine the I. I is current passing through the inductor. Current passing through inductor. Okay. In this question, simply we have to find the initial current and the final current. Then after we have to find use the formula. What is the initial at t is equal to 0 minus. What is the circuit? Simply a resistor circuit and a voltage source 20 volt. Circuit is closed through the inductor. Inductor will be a short circuited. This current is I, which one is the inductor current, and this circuit is open circuit. There is no meaning of this branch of the circuit. It's 2 ohm, this is 5 ohm. In this case, what is the I? 0 minus is the same as 0 plus. There is only a 5 ohm resistor connected in this loop. Then voltage divided by a resistor, it is equal to current, it will be a 4 ampere. Okay. Then what is the final current? circuit at t is equal to infinity. Yes, I have doubts. Yes, you can ask. Okay, at t is equal to infinity, the circuit. Okay, previous question, it means this one. Okay, I can explain this one once more, no problem. In the circuit, simply asking the I2 at t is equal to 0.3 second. Then same thing, we have to find the current. Here is the only one the inductor is there. Then we have to find the current across this inductor, which one asking in the circuit question. Also I2 is current flowing through the inductor. Then current, find the current as initial. Initially means at is equal to 0 minus, because of the initial current at is equal to 0 minus is equal to same as the 0 plus. Then in this condition you can see the at is equal to 0 minus, there is no source of this circuit. If there is no source, that means the current will be 0. Same thing you can apply for the infinity time. At infinity there is a source has connected at 24 ohm. Then you have to find the voltage across this one, this circuit, and then after we have to find the current. Only resistor is 4 ohm is there for I2, and I2 is voltage divided by resistor is 6 ampere is the final current. By the formula we can simply apply the final point is initial minus final e to power of minus t by tau, and we have the current is 6 into 1 minus e to power minus of t by tau. Now you have to find the time constant tau. Tau is in this case L by R. Inductor is one, only one inductor is there. It means 8 Henry is the inductor, but resistor is more than one. In the circuit there is a two resistor. Okay, but we have to make the circuit after t is equal to 0. After t is equal to 0, this circuit is looks like that, and in this condition we have to find the current. Sorry, we have to find the uh, equivalent resistor, equivalent resistance. Then you can see, if there is a source, suppose if there is a source, then this person is independent of this thing. It means how much current is flowing through this branch is not affected this branch in this condition, because of the both are connected in parallel. And you know about for the RTH, to find the Thevenin equivalent resistor, voltage source will be short circuited. If there is a short circuited, it means all the current is passing through this only, not this branch. That's why this resistor will be eliminated to calculation of the RTH or R equivalent for this question. If this branch is eliminated, the only 4 ohm resistor is there to affect the transient effect of the circuit. Okay, because of the both are connected in parallel, it means both are the independent. Okay, the next question, as t is equal to 0 minus, I will find the, I have find the on the voltage current of the initial point is 4 ampere. Then we have to find the current at infinity. Then what is the circuit at t is equal to infinity? This circuit is close to this like that. Okay, This is open circuit. This is closed through this one. At infinity, the inductor will be open, short circuited. This is 20 ohm. This is 20 volt. This is a 40 volt. 5 ohm resistor they here and 2 ohm is here. The inductor is 5 Henry. This is the current which one we have to find current I. Okay. Now what is the current in this case? I at infinity, only 2 ohm resistor is there. Only 2 ohm resistor is here connected in this branch. Then this will be 40 volt divided by 2. This will be a 20 ampere at infinity. And at t is equal to greater than t is equal to greater than 0, then what is the tau? L by R. L is 0.5 Henry. R in this case is only 2. This will be 0.0 or 0.25 second. Okay. What is the IT? IT is simply I infinity plus I0 minus I infinity into e to power of minus t by tau. I infinity is 20 ampere plus I0 is 4 ampere. 4 minus of 20 into e to power of minus of t by dy by 2.25. This will be a 20 minus of 60 e to power of minus 4t. This is the current after t is equal to 0 to infinity. Okay. 20 minus of 60 e to power of minus 4t. This is the answer. First option. Okay. And next question. Sorry. At t is equal to 0, switch is moved from position 1 to 2. Solve for I. S. Pushpak. Yeah, what is your doubt? Okay, in this question simply you have to find the current at initial point and final point, then use the formula. You got the final answer. Okay. Let's go for the next question. If the switch is closed at 1 before that is equal to 0, then after the switch is goes to 2, then at t is equal to 0 minus before the 0, this circuit looks like that. Capacitor will be open circuit and there is only one resistor. This is a 20 ohm volt. This is a 250k low ohm. This will also 250 kilo ohm. We have to find the VC, capacitor voltage, at 0 minus. There is no current flowing from the source because of the all these open circuit. This is open circuit A from here, and this is open circuit from here, this branch. That's why the total voltage appears on this open circuit point. That's why VC 0 minus is equal to same as VC 0 plus, which one equal to 20 volt. Okay. Now at is equal to 0, switch is moved from 1 to 2. Then what is the circuit? At is equal to infinity. This is again open circuit, but switch is closed like that. This is 250 kilo ohm. This is also 250 kilo ohm. This is a capacitor voltage at infinity. There is no source. If there is no source, that means the capacitor voltage at infinity will be 0. It means the whole charge stored by the capacitor will dissipated before that is equal to infinity. Okay. Final initial value is 20 volt, final value is 0 volt. Then what is the voltage equation? Final voltage plus initial voltage minus final voltage into e to power of minus t by tau. Final voltage 0, initial voltage is 20 minus of 0, e to power of minus t by of tau. This will be 20 e to power of minus t by tau. Okay. This is the voltage, but in the question is asking about the current. What is the current? Then, but what is the tau here? Tau in the RC circuit is simply RC. R is C is 1 only, then capacitor's value is given is 500 microfarad and resistor is 250 kilo. From here you can see what is the RTH, R equivalent. R equivalent simply both resistors are connected in series. That's why R equivalent is 250 plus 250 is 500 kilo ohm into capacitor is given as 500 micro farad. 500 micro. Then tau will be 500 kilo ohm. It means 500 into 10 to power of 3 plus 500 into 10 to power of minus 6. Then what is now what number of positive 0? This is 3 0 plus 2, 3 2 5 2 7. It means totally this will be 5 into 5 is 25, 7 0, 6 0 is cancelled out, only 1 0 is there. 250 second. Okay. Then what is the VC? Is 20 into e to power of minus t by 250. Okay. Then after we have to find the current. You know about the capacitor current is C dVc by dt. Or the capacitor is 500 micro. It means 10 to the power of minus 6 into differentiation of this one 20 e to the power of minus t by 250. You can say IT. This is 500 into 10 to the power of minus 6 is a this is a constant, so 20 outside is there, and differentiation e to the power minus t by 250 is minus of 1 by 250 into e to the power minus t, same as differentiation is a power minus t. 252 ja 500 5, that's why 2 is here, 2 into 20 is 40 micro. This will be minus of 40 micro e to the power of minus t by 250 micro ampere. Okay. In this question, simply you have to find the voltage. Then after we have to apply the formula of I in the of the capacitor is C dVc by dt. You can differentiate that equation. Then we will find, we will get the current equation. 40 e to the power of minus t by 250. These are two options. One is a millisecond ampere, another is a micro ampere. Then we have to take the micro ampere carefully about that. Milli and micro. Okay. Next question. In a circuit shown below, possible value of R for which system is under damped will be. Okay. Damping system in the question, it means if there is some elements is there, which one is the uh, damp the response of the circuit. It means there is a voltage is here. It means the current of this circuit will be response. Damping system is three types, which one denoted by the zeta. First one, if this one is greater than 0, which one is the overdamp, also greater than 1 overdamp system. Second one, zeta is less than now underdamped system. Third one is zeta is equal to 1, it's the critically damped. A fourth one, if you want to know, fourth one, zeta is equal to 0 undamped system. This will be overdamped, underdamped, critically damped, undamped system. If you plot in a single thing, it means the current of this circuit is looks like that. Suppose this is the final point, gain 1, this is 0, started from 0. Then the system for the underdamped overdamped system, this will be very slow uh, turning at is equal to infinity. This type of the current is showing in overdamped system. Underdamped system, it means there is some oscillation, then after it will be goes to an steady state. Okay, this type system is shows the underdamped system. Critically damped, it will be fast, goes to steady state. Undamped, undamped system is simply oscillation, oscillatory function. Just make the oscillator like that, continuously at till infinity. This is the undamped system. This is the second order system. Zeta, which one is second order system? We know about the second order system. Response is denoted as s square plus 2 zeta omega ns plus omega n square. If second order system is there, then the system have some frequency, natural frequency, and damping system. Omega n denoted as the natural frequency of that system. It will be oscillatory or not, it depending on the zeta. If zeta is equal to 0 in this case, then what happen? The system will be oscillatory. Why? Because of the s square plus omega n square. 1 upon suppose s square plus omega n square is Laplace inverse is the sin t. Sin t is the oscillatory function. In this condition, in the circuit is asking about the possible value of resistor for which system is under damped system. It is first of all we have to find the current equation. After the current equation, you can says the here is resistor, inductor and capacitor. In any system, if three element is there, it means there is some damping factor is occurs. Suppose this is some voltage source and resistor, inductor and capacitor is there connected in series. Is a DC source, not AC source. Okay, this is the DC source only. If there is a AC source, it means this will be operating very well. There is a no damping types because of the input current is the input voltage is the sinusoidal only. But here is input voltage is DC. In DC system, you know about the inductor and capacitor will not work. Inductor will be short circuit, capacitor is open circuit. But both the system in this condition is here present in the circuit. It means the circuit is having some conditionally operating. Okay, this goes to zero current after some time it goes to zero, but it depends how much time it will take. If there is a long time period it take to goes to zero, it means there is a overdamp system. If there is some oscillatory and then goes to zero, then the system will be underdamped system. And it goes to fastly to zero, that means the system will be critically damped. But sometime if there is a oscillatory only, there is no zero, in that case the current will be system will be undamped system. Okay, this is the output signal of any which one is applied as unity feedback unity input. Then the output, what is the response of output is going here. But in this circuit, if this type of circuit is there and the current is there, then same thing, you know about the current goes to zero because of the capacitor. Inductor is here, capacitor is open circuit after some time, which one after if the capacitor is fully charged, that it behave like a open circuit. In DC case, know about in DC, then current goes to zero, this will be 0 point. Then if the current is suddenly goes to zero, okay, then this is shows as the critically damped. It means zeta is equal to 1. Okay, over damped, this will be take long time to goes to zero. Zeta greater than 1. Under damped, it means it goes to zero, then some oscillatory, then after it will goes to zero. This will be a under damped. Zeta less than 1. Last one is undamped. It means this is a oscillatory. We start continuously like a sinusoidal signal, like that. Continuously sinusoidal signal. This will be a undamped system. What happening? Zeta is equal to 0. Undamped system. Okay, I changed this thing. Okay. Yeah. It means current behaving like behavior is this one. In this case, series RLC circuit. Okay. Suppose t is equal to 0, at t is equal to 0, this will be closed. Then what is the what is the current I in this loop? We can apply KVL in this loop. Okay. What is the KVL? The voltage is equal to current across the resistor I into R plus voltage across the inductor is d I by dt plus the across the capacitor 1 by C integration of I into dt. We can change this thing in Laplace. This will be V by S is equal to R into IS, Laplace of the current, L into S IS di by dt. D by dt is denoted as the S plus 1 by C integration of any system is Laplace is 1 by S, 1 by C into 1 by S IS current. We can take a common IS. Then what is the IS? R plus SL plus 1 by CS SC IS into itna divided by V by S. We can take LCM. Take LCM here. LCM is SC. Okay, take only S is here. Then what happened? S into R plus S square L plus 1 by C is equal to V by S. SS will be cancelled out. Then IS is equal to V divided by of. This will be S square. Take first S square into L plus S into R plus 1 by C. You can take L common. Then V by L divided by of S square plus R by L into S plus 1 by LC. This is the denominator, and this one is affect the system currents because of voltage is constant, L is constant. You know about the second order system. Response of second order system. Second order because of the square is here. Power is 2. Second order. If power is 1 is first order. Response of second order system, you know power this one is omega n square divided by of S square plus 2 zeta omega ns plus omega n square. You can compare denominator. If you compare the denominator, then we will get the omega n square is equal to 1 by LC. It means omega n is equal to 1 by root LC. Okay. And 2 zeta omega n is equal to middle one is R by L. We can put 2 zeta. Then what is the zeta here? Zeta is equal to r by 2l into 1 by omega n. Omega n is equal to 1 by l root lc. R by 2l into 1 divided by f root f lc. This will be r by 2l into root of lc. Zeta is equal to r by 2 root of c by l. Root of l and root of l you cancel out, only root of l is here. L you can retain as under root of l square, and l will cancel out, only c by l is there. This is the zeta. In RLC circuit, you can find the zeta r by 2 and root of l c by l. According to this, you can shows the response. Okay. Simply, in the question is asking about the damping factor. What is the resistance? We have to find the equivalent resistance first of all. L C is series, and then this combination is connected in series. Then what is the R equivalent of this one? Is the 30 parallel with R. This will be 30 R divided by F R plus 30. This is a total equivalent. Then we can put the this one in this equation. For the underdamped, zeta less than 1. Zeta is R equivalent divided by F2 root of C by L should be less than 1. What is the R equivalent here? Is 30 R divided by F R plus 30 divided by F whole 2 root of C by L should be less than 1. We have to put the value of C and L. In the question, C is 0.01, L is 1. This will be 30 R divided by F 2 R plus 30 into value of C is 0.01 divided by F1. It should be less than F1. What is the square root of 0.01? This will be okay 30 R 2 R plus 30 into this will be 0.1. It should be less than of 1. In this case, this will be a 3R should be less than of 2R plus 30 or 60. It means R should be less than 60. R should be less than 60 for the zeta less than 1. It means under damped system. In under damped system, zeta should be less than 1. For the zeta less than 1, it means your resistance should be less than 60 ohm for this question. Okay. It means here in the option is given as A 15 ohm, 60 ohm, 65 ohm and 100 ohm. There 60 ohm is there in this question, but you can't select the 60 ohm resistor because of zeta. For the zeta less than 1, your resistance should be less than 60 ohm, not equal to 60 ohm. Okay, then less than 60 ohm, only one option is there, 15 ohm. we can take here, not a 60. If you put the 60 on, it means the system will be critically damped, not a under damped. Okay. Same thing, suppose in this case, if R is equal to 0, there is no resistance. Is, we will find the Is. Okay. R is equal to 0, it means what is the zeta here? Right there. You know about the zeta, R by 2 because the C by L. Suppose there is no resistor in the circuit. Suppose there is no resistor in the circuit, then what is zeta? Zeta is equal to 0. Zeta is equal to 0. What the case? Zeta is equal to 0 is undamped system. Undamped, it means there is a oscillatory. There is a oscillation. It means there is a looks like a sinusoidal oscillation. Is this one like a sinusoidal? Like that. Zeta is equal to 0. Okay. In your case, Is is V divided by F S square plus SR plus S1 by C. We find the Is, we already find Is is equal to Vs by L divided by F S square plus R by L S plus 1 by LC. In this case, what happened if R is equal to 0? Then what is the Is? Is is Vs by L divided by of S square plus 1 by LC. Vs by L, you can take common. We can multiply here 1 by of root LC. We divide by of 1 by of root LC into S square. We can write as LC whole square. Then what is the Is? Vs is 1 by LC, it goes to upper side or root of LC, and this will be a 1 by root LC. You can write as omega n divided by of S square plus omega n square, because of omega n is equal to 1 by f root of LC, natural frequency. Okay, what is the Is in this case? L 1L is cancelled out. Vs root of C by L into omega n divided by of S square plus omega n square. What is the inverse Laplace of this thing? In time domain, this will be Vs root of C by L. What is this? Laplace of sine omega t. You know about Laplace of sine omega t is omega divided by of S square plus omega square. Same thing here, this will be a sine omega n t. If you take this one is a constant IP, suppose peak current Vs divided by of C by L. Then what is the IT? IT is IP sin omega t, sin omega n t. Sinusoidal signal, you know about the sinusoidal signal? What is the waveform of sinusoidal? 0. Like that. Peak value is IP and minus IP. Same thing, we get this one. This is the zeta is equal to 0. If there is no resistor is there in your system, the current will be oscillatory. It means sinusoidal. Current is sinusoidal. Please care about this system. It means if there is a DC source connected to a inductor and a capacitor. VSLC. If the voltage source, DC voltage source is connected through a inductor and capacitor, then in that case the current of the circuit is sinusoidal, not a DC current. That DC voltage source is converted the current in sinusoidal. If there is no resistance, if there is a resistance, that in case the voltage current goes to 0 after some time. But in the without resistor, only in LC circuit, the current will be in sinusoidal in nature. There is no 0 because of once time is the capacitor will, inductor will charge and capacitor will be discharged. Then after capacitor will discharge through the and charge the inductor. It will be goes like that. Charge discharge phenomenon. That's why current never goes to 0. Okay. Same thing I can explain you later session in Laplace where I teach about the Laplace. I will explain same thing there also. Okay. Let's go for the next question. In the circuit, the switch is closed at t is equal to 0 plus. When the 2 Henry inductor has the initial current of 10 ampere, then the voltage across the resistor is. He is asking about the voltage, not the current. Voltage across the resistor. It means first of all you have to find the current equations, then after you have to apply the equation to find the uh, current equation of this circuit. Then after multiplication of resistor, I into R is the voltage drop across the 4 ohm resistor. Okay. Initial is also already given at is equal to 0 plus IL is initial point is 10 ampere. Okay. Then no need to check for this one. At t is equal to infinity, actually there is no source, that at t is equal to infinity the current will be 0 because of there is no source. This current is IL. Okay. Then what is the current? IL. IL is equal to I infinity plus I0 minus of I infinity into e to power of minus t by tau. I infinity is 0, initial is 10 minus 0 e to power of minus t by tau. This will be 10 e to power of minus t by tau. But we have to find the tau. Tau is L equivalent divided by f r. There is a single resistance, but there is a 3 inductor is there. Then how can you find the equivalent? Simply you can remove this resistor. You have to find the L equivalent here. This will be 2 Henry, this is 6 Henry, this is the 3 Henry. Then what is the total inductance? L equivalent 2 Henry plus this combination is parallel connected to series in this 2 Henry inductor, 6 parallel with 3, 2 plus 18 divided by of 9. This will be a L equivalent is equal to 4 Henry. What is the tau? L equivalent 4 divided by of resistor. Resistor is 4 ohm only. Tau is 1 second. It means IL is equal to 10 into e to power of minus t. Current is here. Then you have to find the voltage across 4 ohm resistor. The current is passing through it. The voltage is through voltage drop VR is equal to 4 ohm resistor and current of IL into T. 4 into 10 e to power of minus t. This will be a 40 e to power of minus t volt. 40 into e to power of minus t. This is the option. Okay. The switch of the circuit has been closed for a long time. It is opened at t is equal to 0. Determine the voltage across 200 ohm resistor. This resistor. The circuit is closed for a long time period. Then after it will be opened at t is equal to 0. Then you have to find first of all initial voltage of the capacitor. Only one capacitor is there here, and 3 ohm 3 resistor is here. Then the circuit at t is equal to 0 minus. The circuit is close to the source, and then a resistor, then after a capacitor. Capacitor will be open circuit, and a resistor here to 200 ohm. Then a resistor is here for 800 ohm. This will be 1000 ohm. This will be 180 volt. We have to find this voltage VC. Oh, the V naught is given. Then you simply take V naught. How can you find? The circuit is closed like that. This will be open circuit. It means there is no current passing through it. This no current is meaning no meaning of this resistor. The whole voltage across the 800 volt is appears on this capacitor. It means we have to find the voltage across the 800 ohm resistor, and these two resistors are connected in series because of there is no current passing through it. That's why the both are connected in series. The series connected resistor, you can use the current divider rule. Sorry, voltage divider rule. Then V naught is same appears at here also. Then V naught as 0 plus is equal to voltage divider total voltage, and resistor across that one is 800 ohm divided by up total resistor 1800 ohm. 1000 plus 800 is 1800. So double 0 cancel out, 18 cancel out, this will be 80 volt. Okay. Now at t is equal to infinity, the circuit is open. It means voltage source is cut out. In that case, this is again open circuit. A 180 volt, 800 ohm, 200 ohm. There is no meaning of this resistor, and there is no source is here. That's why in this condition final voltage is 0. Then what is the voltage? Final voltage plus initial voltage minus final voltage into e to power of minus t by tau. Final voltage is 0, initial voltage is 80 minus 0 e to power of minus t by tau. This will be a 80 e to power of minus t by tau. We have to find tau. In this case is RC. Capacitor is only 1, resistor is 2. At is equal to 0, this is the circuit. You have to find the R equivalent. In this case, the current is flowing like that. It means both resistors are connected in series. This will be 1000 into C capacitor. Capacitor is 100 micro. This will be 0.1 second. What is the VT? 80 into e to power of minus t by 0.1. This will be 80 e to power of minus 10 t. Then what is the circuit at t greater than 0? Only this circuit is there, the capacitor, and this is voltage of the capacitor. Then this voltage is divided into two parts because of the both Resistor are connected in series, that's why you can apply same voltage divider. VR T is same VT into 200 ohm divided by of total resistor 800 plus 200. VT is 80 e to power of minus 10t into 200 divided by of 1000. 30 cancel out, 8 2 ja is 16 e to power of minus 10t. This is the voltage across the 200 ohm of resistor. Sorry. Simply, first of all, we have to find the initial voltage of this capacitor. For making the circuit at is equal to 0 minus, this will be open circuit, and the whole voltage is appears on these two resistor only, which will connected in series 1000 ohm and 800 ohm. Then across the 800 ohm voltage is same as the capacitor voltage, initial voltage, and you can simply apply the voltage divider and you will get the initial voltage of the capacitor, which one is the 80 volt. Then at the final, you know about if there is no source, the final voltage will be 0. You can skip this part also. Sorry, you can skip this false part. There is no meaning of this part because of there is no source. If there is no source, then simply you can write the 0 voltage. You can use formula 80 e to power minus of t by tau. It means if there is no source, at final, then the volt V 0 e to power of minus t by tau. If there is a source, okay, at t is equal to 0, infinity, but voltage at 0 is equal to 0. There is no initial voltage. If there is no initial voltage, then there is a V applied voltage e to power of minus t by tau. So write this type of equation. If the initial voltage is 0, if the final voltage is 0, or you can say if the final voltage is 0, you can apply this thing. If the initial voltage is 0, you can apply this thing. If both is present, then you apply this thing. V infinity 1 minus t power 40 by tau. Then if you find the voltage across the capacitor, then after you have to calculate the tau. It will be the R equivalent into C. Then after you have to find the voltage across this 200 ohm resistor. This the whole voltage this voltage V naught is appears across these two resistor only, 800 ohm and 200 ohm, and both are connected in series. If the both are connected in series, then in this case you can apply simple voltage divider rule. We have to find the voltage across 200 volt, write the 200 volt above divide by f total resistance, and we will get the final value of 16. 16 e to power of minus 10 t. Okay. Okay, everyone, I want to stop here. You can meet at next class at 7. Then after maybe class at 9 October also, 9 and 12, then 14 and 16 like that. Okay, there is a 7, 9, 12, and 14, 16 class. There is a one band extra class also here. That's why. Okay, and I'll explain the law of loss and total law of loss theorem, and explain the how can you apply the law of loss in your network system, and how the makes the circuit easy to solve this. A complex circuit you can solve by using law of loss. Okay, okay, thanks to all.